You have heard that Qubit is 0 and 1 at the same time. That's also a single misleading set of quantum computers. What actually is and where 0 comes from. Start with the thing a qubit is replacing. Every normal computer runs on bits, and a bit is the simplest object there is. A switch that is either off or on, 0 or 1. Everything on your phone, every photo, every message is just billions of those switches. A qubit is the quantum version of that switch, and the temptation is to say it is just 0 and 1 at the same time. But that phrase hides what is really going on, and it leads people straight into nonsense. So let us build it properly, one honest step at a time. Here is the honest version. A bit is a switch, only fully off or fully on. A qubit is more like a dimmer dial. It can sit at off, at on, or at any controlled blend in between, leaning mostly toward 0 or mostly toward 1, by an amount you can set precisely. That in-between setting is what physicists call superposition. The key word is blend, not both. The qubit is not secretly a 0 or a 1 that you cannot see. While you are not measuring it, it genuinely sits at a dialed-in mix. And because you can steer that dial, you can load information into the angle of the blend itself. But a blend by itself is not the magic. Plenty of ordinary things sit in between. The real power is something called interference. Think of noise-canceling headphones. They beat unwanted sound by adding a second wave that is the mirror image of it. So the two cancel out and you hear silence. A quantum computer does the same trick with answers. Each qubit blend carries a wave, and a clever quantum program is designed so that the waves for the wrong answers cancel each other out, while the waves for the right answer line up and reinforce. So a quantum computer does not try every answer at once, the way the myth says. It arranges for the wrong ones to erase themselves and the right one to ring out loud. That is the whole game. So why all the confusion about 0 and 1 at the same time? Because of what happens when you look. You can never read the blend directly. The moment you measure a qubit, it is forced off the dial and onto a single definite answer, either 0 or 1, and the odds of each are set by where the dial was pointing. Lean the blend toward 1, and you will probably, but not certainly, read a 1. This is the part people garble. Before you look, it is a real blend. The act of looking is what forces the single answer. The whole art of quantum computing is steering the blends with interference, so that when you finally measure, the answer you want is overwhelmingly the one that comes out. That clears up two traps you will hear constantly. Trap 1. A qubit is secretly already a 0 or a 1, and we just cannot see it. No, if that were true, interference could not happen. A hidden, already decided value has no wave to cancel or reinforce. And quantum computers visibly do use interference. Trap 2. The one that matters for the headlines. More qubits automatically means a more powerful machine. Not so. 1,000 sloppy, noisy qubits can be useless, while a few extremely accurate ones can be genuinely powerful. Quality, how cleanly each qubit holds its blend, matters at least as much as the count. So when a press release shouts a big qubit number, that number alone tells you very little. So here is the qubit, honestly assembled. It is the quantum version of a bit, but instead of a fixed off or on, it holds a steerable blend of 0 and 1. That blend carries a wave, and interference lets a program cancel the wrong answers and amplify the right one. And the instant you measure, the blend collapses to a single 0 or 1. Blend, interference, measurement. Those three ideas are the whole foundation, and almost every quantum headline you will ever read is really about one of them. On our map, we are still right at the beginning, but now the ground under the rest of the story is solid. A qubit isn't both at once. It's a blend you can steer. Quick recap. A qubit is a steerable blend. Interference is the real engine, and measuring forces a single answer. Hold on to one practical takeaway. When you see a headline bragging about a giant number of qubits, remember that the count alone says almost nothing without quality. None of this is financial advice. It is just the literacy that lets you judge those headlines for yourself. And there is one more idea that turns a pile of qubits into something genuinely strange and powerful. What happens when two of them become linked? That is entanglement, and it is next. One qubit is a blend,